Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss about survival analysis. It's a branch of statistics. It's also known as event history analysis in social science, reliability analysis in engineering. Basically, here we deal with an event of interest. Means that we are interested in a particular event that should happen in a particular time frame. Now, what's the event of interest? Let's try to understand. If I talk about survival analysis in medicine, and the example is the patients who are infected with HIV. So I am carrying out a study, the time span or the lifespan of these people who are in fact who are having an infection of HIV. So in this time frame, say for example, if the study is conducted for 1 year, the desired event of interest is death. It means that from infection to death, what is their lifespan we want to study. So the desired event of interest is death. If we talk about reliability analysis and engineering, the same concept. After the installation of the machine, when the parts fails, that is a desired event of interest. In survival analysis, the subjects are usually followed over a specified time period. The focus is on the time at which the event of interest will occur. I have already explained. However, it is possible that in this time frame, desired event does not happen, and this is known as a censored observation. This happens when a subject leaves the study and the time of event is not known precisely. Depending upon this, there can be two type of censoring which can happen. One is left censored and another is a right censored. Let us try to understand by this small plot. Say for example, these blue lines are my time of study. These blue lines are my time of study. We have started the study from here and we are ending the study here. The desired event happen after we wind up the study, and therefore it is a right censored. It may also be possible that that we are not aware about when the person got the infection, HIV infection, and when he leaves the study, he is not continuing the study with us, and what happened to him, we are not aware. So that is less censored. Now, why survival analysis is very typical in comparison to other types of analysis? The first thing is, at the same time, all individuals do not enter the study, and this makes it very unique. The second is, the event of interest has happened to some individuals even when the study ends. Has not happened, sorry. It may happen that the event of interest has not happened at all, even when we wind up the study. The third is, some individuals drop out or get lost in the middle of the study. So the first feature is known as a staggered entry. The last two relates to the censoring of the failure time event. What's the difference between regression analysis and survival analysis? In survival analysis, dependent variable is composed of two parts. One is time to the event, and other is the event status. Normally, in case of linear regression, we are having only one dependent. While in case of survival analysis, we are making a model both from censored as well as uncensored observations in estimating the important model parameters. The important functions which we have to remember in survival analysis are survival and hazard functions. These are key to understand how to describe the distribution of event times. To describe the survival times of members of group, following functions are used. Life tables are used, Kaplan-Meier curves will be used, survival function will be used, and hazard function. To compare that is the survival rate different in two groups, that is the survival rate different in male and female, those who are diabetic, non-diabetic, is it different or not? We are using log rank test. To describe the effect of categorical or quantitative age, then we are using another type of model like Cox proportional hazards regression, parametric survival models, survival trees, survival random forest. What are the variables under the study? They are time variable and it must be continuous. Second is status, binary or categorical variable, which basically represents the event of interest. That is death, alive, failure, success. The factor value variable will be categorical. Now let's try to understand. Now let's try to understand the Kaplan-Meier Estimator survival function, how it works. When we started the study, there were 30 patients who were considered. 3 died, and 20, it means that 27 survived. So we will be taking the ratio of 27 divided by 30.90. In the second time period, 27 entered in the study, 2 died, so 25 are left. So 25 divided by 27. In third time period, 25, 1 died, so 24 divided by 25. Now a very unique thing which has happened in our times in our study is 1 left the study. So now what it will be? 24 minus 1, 23. 6 died, 17. So 17 divided by 23. Again in fifth time period, 17 entered the study, 2 died, so 15 divided by 70.59. In 8 time period, 15 and 15 survived, 6 left the study, so 15 minus 6, 9. 1 died, so 8 by 9. So this is a way Kaplan-Meier estimator survival function is calculated. The data set which we will be using here is a cancer data set to understand survival analysis. Let us see how we can do this in R. First of all, you will have to load the library survival. Activate the library and you can see the cancer dataset is active. At any moment of time, if you want to see what are the variables which are there under the study, write down help and the dataset. On right hand side, you can see the first one is the institution code, time, survival time in days. Status is censoring test status. 1 survived, 2 dead. Age in years, male, female, pH echo, pH Carnot, patch Carnot, meal calories, and weight loss. Now I'm activating the survival function and I'm saying KM survival I'm creating. Survfit is the command line. Serve time, time is this, status tilde 1, and I'll run it. First of all, I'll have to activate the cancer, run, and KM survival I will get. The number of events which have occurred are 165. I will generate the summary by writing KM survival and I'll get the full plot, full tables. Now here, what we have to see is this time means 0 to 5. This time means 5 to 11, right? This means 12 to 13 and this means 13 to 14. So 0 to 5, 5 to 11, 11 to 12, 12 to 13. That is time. This we will have to read like this. Now at time period 0 to 5, 228 people are at risk because we are just starting the study. The number of events which have occurred in this 0 to 5 is 1. So what is the survival here? It is 0.9956. The standard error is 0.00438 and the standard error, it means that the lower 95 is 0.987 and upper is 1. Now it will generate the table for the entire time period and it will tell me that what is my survival rate till last, right? Now I can plot the same thing, same table. I can get the plot KM survival. X label is time, Y label is survival probability. On right hand side you can see this. To get the proper you can say proper curve, load the library survminer and generate GG surf plot fit survfit surv time, comma, status, same, tilde 1, data is cancer, X label is time, Y label is survival, probability. Run. First of all, I will have to activate the library. On right hand side, you can see the curve. We will have to understand this curve vis-a-vis the table. So now here, this you can say whenever there is a drop, see whenever there is a drop, it means that the event has occurred. So a drop means the event has occurred. And the plus sign means that the this observation is censored. So how to read this curve? Let us understand. At time t is equal to 0, no event has occurred and all the subjects are alive. Here, all the subjects are alive. And therefore, all are having a risk. And any event in KM plot is indicated by a vertical drop, and the plus sign means the censored observation. Now here, what do I mean to say by this? The probability of survival between the time interval 0 to 5 is 99.56. 99.56, and it can fluctuate up to 98.71% or 100%. Now I want to see that is this curve, survival curve, is it significantly different in male and female or not? So for that, what I'll do, KM survival, survfit, serve time, comma, status, tilde, instead of 1, now I am giving the categorical variable, run, run. And you can see it gives me that in case of gender 2, in case of gender 2, 53 events have occurred, and in case of gender 1, 112 events have occurred. But the question is are these events, are they significantly different or not? So for that, I'll be running KM survival 1. And therefore, I'll be able to get two different survival tables, one for gender 1 and another for gender 2. I can also get the survival for the different time periods. That is, I'll specify that what is the survival from 0 to 50, 50 to 100, 100 to 150. I can run it. So I'll get this. The number of events which have happened in case of gender 1 in time period 0 to 50 is 10, 50 to 100, 14, 100 to 150 is 12. In case of gender 2, 0 to 50, 1 event has happened. 50 to 100, 6 event has happened. 100 to 150, 4 event has happened. The same thing, I can plot it. Plot KM survival 1, X lab, Y lab, color black and red, run. And I'll get two different curves representing the difference in the survival. Now, how to read this plot vis-a-vis this plot? So if I talk about gender 1, the probability of survival for male between time intervals 0 to 50 is 92.8%, and that for female is 98.9%. The probability for male for 50 to 100 is 82.6%, and that of female is 92.2%. Here male is 82, here 92. Here 73.9, here 87.7. Now we want to see that is this difference significant or not. And for that we perform a log rank test. Basically, A log rank test is used in survival analysis when survival times of two or more groups we want to compare. So here we want to compare the survival times of according to the gender. What I'll do is serve time comma status tilde gender. I'll run it. The null hypothesis is there is no significant difference in the survival of these groups. So here you can see the p-value. So as a p-value of log rank test is less than 5% level of significance, we reject null hypothesis, which means that survival is significantly different according to the gender. Now, when we are including the predictor variable like weight, age, blood count, normally the Kaplan-Meier plot will fail or Kaplan-Meier curves don't fit well. And therefore, it is necessary to use Cox proportional hazard for this purpose. And how we will be using it? So, NA survival, survfit, Cox pH, everything remains same. So, time, comma, status, tilde, type is ln, NA survival. So, it will also give me the same summary and plot. This is to be used only in the scenario when you are having a predictor variable which are quantitative like weight, age and blood. Normally, Cox proportional regression models does not have assumption of the normality. It is also known as a semi-parametric model. The semi-parametric, and there are no assumptions of shape. That is a baseline hazard assumptions are not there. Okay. Now I want to see the effect of age, gender, pet Carnot on the survival time. Now what I'll be do, first of all, I'll create the data frame. And this is Columbine, X, Columbine, age, gender, pet Carnot, activated. So I'll say Cox pH. Now everything remains same. X will come from here and method I'll be using Breslow. And I'll see its effect. It will give me the summary. Now here you can see the p-value of age is more than 0.05 and therefore this variable is not at all contributing, or rather the survival is not dependent on age. You can see here the p-value of gender is less than 0.05 and therefore it means that the survival rates are different in male and female. Similarly, the case of expat Carnot. Now here, just see the sign of gender, 0.518. It is negative. The sign of coefficients in the Cox equation indicates the hazard of second group relative to the first group. That is female versus male. The variable gender is coded 1 as male and 2 as female. So a positive sign means that the hazard, that is a risk of death, is higher. Beta coefficient for the gender is 0.518. It indicates that the female have lower risk of death, lower survival, that is lower risk of death than males. Now see this coefficient 0.595. Just see this, right? Or minus 0.518 exponential. I'll get the answer as 0.595. This is the hazard ratio. What does it give? It gives the effect size of covariates, which means that the females have 0.595 times the hazard of dying in comparison to males. Okay, it gives me this 0.59 gives me the hazard ratio, basically known as odds ratio. It says that females have 0.595 times the hazard of dying in comparison to males. Just a minute. This means that as females are coded as 2, it reduces the hazard by a factor of 0.59 or 41%. It means that females are having lower risk of death than males. You can also see the confidence intervals, that how much it can fluctuate. You can also see that thing. 0.95, and it can fluctuate from 0.9935 to 1.031. It also gives that thing. You can also use R-part library. This one. Basically, it's a package that contains recursive partitioning for classification, regression, and survival tree. Just activate the library and survival time status tilde. Specify all the predictor variables here with the model, run, fit, and again plot, and plot fit uniform true, branch 0.4 compressed true, text fit use dot n true. Now see, it gives me the decision tree. Now let's try to understand this decision tree. So this is a decision tree for the cancer dataset. The terminal node indicates the number of subjects which are there. Number of subjects who have events and the relative rate compared to the root. A split on the value of the variable is indicated by each branch. This is a split. Now here, if I talk about ph.eco less than 1.5, yes, then you have to go on this side. No, you have to go on this side. Is there any weight loss greater than or equal to 21? You will say if it is yes, you will come this side. No, you will go on this side. Gender greater than 1.5, you will come this side. So it will give me the survival rate based on the classification which it has identified. The classification will be done on the purity of the node. It's an algorithm. It will try to identify the variable which has got the purity. So now let us try to understand something more in this. Okay. If I talk about this one, all those patients whose ph.eco was less than 1.5, gender was greater than 1.5. So it means that it is 2, gender is 2. 37 events have occurred out of 69 patients. Right? So it talks about the survival according to the variable. So this is all about survival analysis. All these codes are available in my book, Data Analysis Using R. It is available on Amazon.in as well as Amazon.com. You can follow me on LinkedIn and Twitter. Kindly subscribe to my channel. Thank you.